Now that we have a model to describe the freezing point of the saltwater mixture, the solute water mixture, let's actually calculate how much the freezing point temperature changes when we're dealing with seawater as to compare it to pure water. Okay. All right, so we're going to deal with water that has a 3.5% salinity. And what's meant by that is that for every kilogram of water that you have, there's about 35 grams of NaCl in it. Okay? All right. So that just means that there's 35 grams of NaCl for every 1 kilogram of water that we have. There's one subtlety that we have to think about when we're dealing with salts, and that's when salts dissolve. They typically don't stay as one molecule, but instead they form two molecules, Na plus and Cl. Okay? All right. And so because we're dealing with two molecules that have two different molar masses, to kind of simplify this analysis, we're actually going to think of an average molar mass of Na and Cl. And that average molar mass is about 29 grams per mole. Okay? All right, so we need this molar mass because we need to calculate some mole fractions in a bit. But to do this calculation, we also need to take a basis, since we aren't really told an extensive amount of water. So let's just say we're taking a basis of 1 kilogram of water. So that means that we're dealing with 35 grams of salt. Okay? So to figure out the moles of salt we're dealing with, we have 35 grams divided by 29 grams per mole. So that means we have 1.2 moles of salt. We now need the moles of water. So we have 1 kilogram, which is 1,000 grams. Molar mass of water is 18. That means we're dealing with 55.56 moles. So the mole fraction of salt that we're dealing with in our mixture, which is N salt divided by N salt plus N water, that's going to be 0.0211. So about 2 mole percent. Okay. All right, so now that we have that, we just plug into our model. So I'll kind of write this explicitly. This is the temperature at which salt water freezes. That's just going to be equal to T1 over T freeze of pure water minus R over delta HM, which we are given in the problem statement, minus 1 minus the salt in the mixture. And all this to the negative 1. And so, remember, when you're doing these calculations with temperature, use absolute temperatures. If you plug everything in, you get a temperature of 271 Kelvin, which is equal to negative 2.2 degrees Celsius. Right? All right, and so what this is showing is by putting in salt into this water, the freezing point temperature of the water goes down.